Welcome to this webinar on energy efficiency gains in upgrading desiccant air dryers. My name is Upanita Burman, and I am Digital Account Manager working at Parker Hannifin Sales Company UK and Ireland. Just before we start, I would like to give you some information on the participants and the webinar. The webinar will be recorded and the recording will be provided to you at the end of the webinar. All participants will be on mute throughout the duration of the webinar. Please note, we will have a Q&A session at the end, and all participants will have the opportunity to ask your questions. Please feel free to submit your questions in the Q&A box at the bottom. With that said, I would like to introduce our speakers, Alan Dolby, who is the Managing Director of Direct Air, and Joost Huting, Sales Manager for the Filtration Division of Parker Sales Company UK and Ireland, who will be speaking about the importance of compressed air systems and how upgrading them can save you major costs and increase efficiency. Over to you, Alan.
Thank you. Morning and welcome to everybody. So my name's Alan Dolby. I'm the Managing Director of Direct Air and Pipework Limited. So Direct Air, we were formed in 1993 and we're committed to providing the highest level of technical support to our customers for all of their compressed air requirements. So we provide service installation support to companies throughout the United Kingdom from our centrally located Coventry and Gloucester facilities. And of major importance to us when considering any compressed air system is ensuring that the system delivers not only reliable, but also an efficient supply of compressed air. Direct Air's strength as a leading UK distributor of compressed air equipment is largely due to the high quality suppliers that we partner with. We've been an authorised distributor with Parker Hannifin compressed air products for many years, and we've recently expanded on this with the launch of our new sister company, Direct Cooling. Direct Cooling specialises in providing equipment and solutions for process cooling requirements. And so today, our partnership with Parker covers a full range of compressed air treatment products, nitrogen generation products, and now process cooling equipment. But your system comprises more than just the air compressor. And whilst it's important to consider the efficiency of this, it's only one small part. Compressed air treatment provides a critical part in all compressed air systems. Firstly, it's essential that the appropriate equipment is installed to ensure the required quality of compressed air is delivered to your system and downstream equipment. But additionally, the efficiency of this treatment equipment and its installation should also be taken into consideration. When considering a compressed air system, the overall cost of compressed air generation is what needs to be considered, and not just the efficiency of the compressor itself. Compressed air is often termed the fourth utility, and it's a vital part of any facilities, not only now in manufacturing, but also distribution and many other sectors. But it comes at a cost and will typically represent between 2 to 40% of a facility's total energy requirement. And this is why the efficiency of the system is vitally important, with 70% of the compressor lifetime cost related purely to energy. So this is where Direct Air can assist you. For all systems, we would always recommend that a compressed air energy audit is carried out so that a detailed assessment of the cost to generate your compressed air is fully understood. Our audits, conducted in compliance with ISO 11011, enable us to effectively monitor energy consumption, system pressure, and, when required, flow and dew point. We'll provide you with a report with details on how your current system is performing, and where appropriate, provide recommendations on any improvements that are possible with a return on investment calculation. We also offer additional services that complement our energy audit works, including air quality testing for systems that require the highest quality of air and need to be tested regularly. And unfortunately, most compressed air systems will have leaks. And Direct Air can provide a leak detection service using ultrasonic equipment that assists in identifying where these are so they can be tagged and repaired by your maintenance team. At Direct Air, we typically are auditing numerous sites monthly. One example is shown on this slide, where a pharmaceutical customer of ours wanted to start production at a UK facility. Their existing system had old, unreliable, and inefficient equipment. So we carried out an energy audit, and at that time identified energy savings of £27,000 per annum with the installation of new compressor technology. This was in 2017, when electrical costs were significantly lower than today. The company decided to proceed, and following completion of the project, the subsequent post-installation audit highlighted that the savings were over double the original projected numbers. So I can't promise everyone that this level of improvement is possible on every site, but feel free to invite us in to carry out a free initial assessment of your system so that we can advise you further on how we may be able to help you. So thank you for your time, and I'll now pass over to Joost.
Thank you very much, Alan. As Alan pointed out, energy consumption is a significant component of a compressed air system and the ongoing cost of running that system. Therefore, this morning, we're looking at potential energy efficiency gains in upgrading desiccant air dryers in your system. My name is Joost Heutink. I'm the sales manager for UK and Ireland for Parker Hannafin's filtration division. I'll be happily take your questions at the end of this session. Please put them in the Q&A section of the chat. First of all, compressed air is a vital and versatile utility and energy source in most manufacturing industries, but it's plagued by a number of potential contaminants that, when left untreated, can cause damage to the pneumatic components in the system, as well as the products with which the compressed air is in contact. This contamination can come from the ambient in the form of water vapor, microorganisms, millions of dirt particulates or solid particulates per cubic meter of ambient air that are drawn into the compressor, as well as unburned hydrocarbons and oil vapors from industry, traffic, and other sources. When that air is compressed in the compressor, there is potential additional contamination that may come in the form of liquid water, lubricating oil, and wear particulates. Even downstream of the compressor, from the receiver, the pipework, and other components in the compressed air network, you can have additional contamination. As said, if left untreated, this can cause serious efficiency losses in the system, as well as damage and increased maintenance. It's therefore common practice to install a compressed air treatment system downstream of the compressor to eradicate a lot of this contamination. To what extent this is required will depend on a number of factors. In the first instance, compressed air purification systems can increase reliability and durability of the system by reducing wear, corrosion, leaks, etc. There may be process imperatives, for example, where air is in contact with a powdery substance like cement or flour. If you're pushing that product along with wet air, the product will clump together. Or there may be safety issues, such as for critical instrumentation. It may prevent freezing in the pipework where there is external pipework. There are industry standards, particularly related to food and beverage and pharmaceutical, where written best practice guidelines are given out to advise on what the best available air quality requirement is. Some equipment manufacturers may have their own specification as well. It often specifies in the user guide what the flow, pressure, and air purity requirement is for that equipment. And some multinational corporations may have their in-house specification. In certain cases, such as for breathing air or medical air, there's even legislation detailing the air purity requirements. Rather than using vague terms such as I need dry air or I need clean air or oil-free air, there is a written specification that classifies air purity according to three main categories: solid particulate, water, and oil. So this means that both an end user can specify the air purity requirements to the supplier, and the supplier can specify the air purity specification that they are providing with their solution. So there's therefore an agreement between the parties as to what is supplied and what is needed. You can also test air purity in accordance with this classification, which can be written out as an ISO 8573-1 2010 class XYZ, where the lower the number, the higher the purity specification. How do we achieve this air purity specification? Well, Parker can provide a range of products that supply any air purity specification in accordance with ISO 8573-1. Water separators can reduce the bulk liquid water and oil content in the air. Coalescing filters can remove smaller droplets and aerosols, as well as solid particulate. Oil vapor removal filters or activated carbon filters will remove oil vapor. Between them, they remove 8 out of the 9 compressed air contaminant classes, as you can see in the below table. The only thing that's missing is water vapor, and we'll talk about dryers a little bit later on in this presentation. What is important to note is that all of these products are independently and third-party validated by Lloyd's Register, which is of very high importance for audit purposes for critical applications, for example, in the food and beverage and pharmaceutical industries. This handy table summarizes the type of products and the grade of filtration that's required to achieve these air purity classes. It is noteworthy to state that both for oil-free compressors and oil-lubricated compressors, the same level of filtration is required, taking into account the contamination that could be coming from the ambient air. How we achieve this specification in reality can be determined by a site survey, with Direct Air and Parker collaborating to determine the best possible solution. This setup, for example, has a relatively rudimentary air purity system in the plant room with a refrigeration dryer and some filters, and any critical points where air purity specification is higher, local point of use filtration can be installed. This could include, for example, breathing air, oil-free air for food and beverage applications, or merely just a particulate filter to ensure that any particulate captured in the pipework will be retained. Another example, such as this, we have a much higher air purity specification in the plant room, and then some point of use filtration, perhaps to a smaller degree at the point of use. This is particularly useful for critical applications such as food and beverage, where you have, to some extent, you have a double security around air purity specification, where we're treating the air in the plant room as well as at the point of use. Again, Direct Air and Parker are very happy to attend your site and to make recommendations as to the optimum solution, as no two sites are the same. So we come to compressed air drying now. We looked at shortly at filtration products, which remove 8 out of 9 contaminants. However, water vapor and liquid water is by far the largest constituent of the contaminants in the compressed air system, and therefore needs some attention, special attention. There are a few different types of dryers in industry, the main ones being refrigerant dryers and desiccant dryers. Refrigerant dryers are the most common dryers. They cool the air down and remove water vapor from the air, and can achieve ISO 8573-1 class 4, 5, or 6 for water content, which means it can go down to a 3-degree pressure dew point. Moisture content typically between 700 and 1100 milligrams per cubic meter, And it's used generally for general industrial applications and typically installed in plant rooms. It can also be used as a pre-dryer for desiccant dryers. Desiccant dryers dry through absorption. There's a desiccant media inside, which we'll talk about a little bit later, that can achieve very low dew points, including class 1 for water content, which is a -70 degrees dew point. Most desiccant dryers would be used for class 2, -40 dew point, which is 70 times drier than the air purity required achieved by a refrigerant dryer. Desiccant dryers are, however, more expensive to buy and to run than refrigerant dryers, and therefore tends to be used for more critical applications, such as food and beverage and pharmaceutical, or where process imperatives require the air to be particularly dry. It also impedes microbial growth in the compressed air. Desiccant dryers can be installed in the plant room or smaller desiccant dryers at the point of use for specific high purity applications. So how do desiccant dryers work? A media called desiccant, or a desiccant agent, such as alumina or molecular sieve, is used to dry the air. The air passes through this medium, which is inside of the desiccant dryer, and the air coming out is of a very low degree of moisture content. There typically in a desiccant dryer will be 2 columns, where one is drying and the other one is regenerating. After a period of time, the offline column will be, or the online column will be saturated, and we have to switch to the other column and regenerate that desiccant. This is done by a valve system where a set of valves will direct the air through a column A or column B. The drying principle is pretty much the same from one type of desiccant dryer to another, but there are various regeneration methods. It could be a combination of compressed air, heat, or vacuum that is used for regeneration. These different types of regeneration methods have a very high variation in terms of energy costs required. The regeneration air is exhausted to atmosphere. This is a cyclical process where we switch from one column to another and back again, and there is an additional option to monitor the outlet dew point so that we can extend drying cycles and save energy. Parker can supply a range of different types of desiccant dryers. The simplest type of dryer is a heatless PSA dryer, which just uses dry compressed air for regeneration. However, it uses up to 20% of the compressed air capacity of the dryer for regeneration. Therefore, the operating cost also tends to be the highest. Depending on whether dew point dependent switching is installed or not, this energy costs could run into thousands of pounds a year. For larger systems, anywhere from about 5 cubic meters a minute or 200 CFM, more energy efficient types of dryers would be recommended, such as dryers regenerated with vacuum, which reduces the purge rate down to 3%, or even using external air, heated external air brought in through a vacuum pump, which doesn't require any compressed air for regeneration at all. We also have hybrid dryers, which is a mixture between refrigerant dryers and desiccant dryers, which is ideal for very low dew points, as well as providing potentially seasonal dew points. So for example, if there's external pipe work and you require a low dew point during winter to prevent freezing, but you can run it as a refrigerant dryer during the summer. Which dryer would be best suited to the application will be down to the specifics of the application. And again, we'd be very happy to discuss this with you and select the correct option. This will hopefully be largely determined by the total cost of ownership, as the capital and installation cost, which are often hotly debated at the project stage, actually only correspond to a very small proportion of the total cost of ownership of any system. What's much more important is the running cost, and therefore the direct energy consumption, as well as the purge air consumption, the maintenance cost, and the product reliability, of course, as well. Downtime costs is often forgotten about, but a day's downtime could correspond to as much as the capital cost to put this equipment in the first place. And therefore, it is recommended practice to have duty standby system at all time to ensure 100% uptime of the system. We talked about purge airs and a heatless dryer requiring 20% of purge for regeneration. This can add up to a significant amount of energy, as desiccant dryers tend to be switched on 24/7 to ensure continuous dew point performance. Without dew point dependent switching, so standard cycling, you would use up to 55,000 kilowatt hours of energy per year for a relatively medium-sized system at 5 cubic meters a minute. At current energy costs, it would be somewhere between 10 and 15,000 pounds a year for a relatively minor system. A variable cycle dryer with dew point dependent switching can reduce this by up to 90%, as cycle times can be extended from 3 minutes to 30 minutes. We have also other options, as pointed out, with lower generation energy requirements. So reducing the purge requirement and using either vacuum or heat to regenerate, and we can achieve energy savings up to 70% beyond the DDS heatless version. On top of this, when selecting a compressor size, you would need to take into account the purge losses that are present from the desiccant dryer, which is an extra burden on the demand of the compressor. And it also increases the running hours of the compressor. So this opens the door to potential upgrades to your existing system. Many dryers would have been installed some time ago, perhaps not with the best advice, or perhaps more efficient options have appeared on the market since. So why would we want to upgrade any old desiccant dryers? First of all, as we were talking about here on the webinar, there's a potential for energy savings and carbon footprint reduction. More and more companies are targeted with energy reduction as well as becoming greener. Wasting 20% of compressed air is a luxury that few companies can afford. Installing a new dryer may also improve the air purity specification. If there is no dew point control, a dryer with dew point control can actually show real-time dew point monitoring. The performance of the product may not be as it should be. There may be safety issues with an aging product. There could be component and spares obsolescence. Or maybe the dryer is no longer fit for purpose, as the site may have expanded and the dryer is either too small or the dryer is too large and therefore inefficient. The simplest thing to do would be to upgrade an existing heatless dryer with a new controller that incorporates dew point dependent switching. This is compatible with most heatless dryers, though not all. So we can install a new controller on an existing dryer, offering you dew point dependent switching at a relatively minor cost and save up to 90% of running cost on that dryer. Payback is typically well within 12 months for this. However, perhaps this dryer is old, inefficient, unreliable, or spares may be hard to come by, and you want to upgrade the whole dryer for a new CDAS or OFAS Parker dryer. The cost of this new dryer could potentially be offset against the cost of overhauling the dryer. So it might require new desiccant, new valves. So you may be spending a few £1,000s on this dryer to begin with, which you can offset against the cost of a new dryer. The new dryer will have 5-year parts warranty, long service life, and third-party performance validation. And on top of that, if the existing dryer does not have dew point independent switching, savings up to 90% of operating costs. We've done this on a number of sites, and typical payback we've seen is ranging between 15 and 30 months for this type of upgrade, which can often be relatively simple as a direct replacement of the existing dryer in the pipework. For larger systems where heatless dryers are installed, whether they have dew point dependent switching or not, there is an opportunity to save energy by installing a low energy dryer, such as in this case, as you see on the pictures, where there was a site with 8 heatless desiccant dryers, where we replaced those dryers with 0 purge dryers. The investment for this particular customer was probably in the region of about £600,000, but payback was in 2 years' time. They also increased the site air availability by 40% because of the purge air reduction from the existing dryers. So this is another option to look at energy efficiency gains for larger heatless dryers. However, even if the dryer that was installed is relatively efficient, such as our old heat regenerator dryers, which you can see some pictures of here. I know we brand ourselves as Parker, but we are also part of, Dominic Hunter is also part of Parker. And sorry about that, the fire alarm. Dominic Hunter has supplied desiccant dryers into the UK market for about 40 years. They're built in the UK, and therefore in their home market, there must be thousands of these dryers out there. And we've been upgrading them with our vacuum regenerator dryers, as you can see on the right-hand picture there, for the last number of years. This has improved energy efficiency, as well as improving system reliability and the air available on site. These modular heat regenerative dryers have been a workhorse for 30, 40 years now and been very reliable, but components may no longer be available, and reliability of these dryers can often be suspect after so many years. Again, upgrading typically has a payback within 30 months. So let's look at a few cases where we've upgraded existing desiccant dryers. On the left-hand side, we have an old Dominic Hunter heatless desiccant dryer without dew point dependent switching, which means that it is constantly cycling, which is a little bit like running your heating system without a thermostat. You're constantly heating the room, whether the temperature is high enough or not. In this particular case, if the dew point is good enough, why keep cycling and regenerating? So this is putting a high load on the compressor, with the compressor running cost spiraling out of control. And also there is no performance monitoring on this dryer. It is cycling, but there's no way to check what the actual performance on the dryer is unless you bring in a portable hygrometer. For this relatively small system, the operating costs were about £7,800 a year, with an annual air loss of 290,000 cubic meters. It required new desiccant in valves, which was going to cost about £2,000. On the other hand, a new system, our Parker CDAS dryer, with dew point dependent switching, third-party performance validation, continuous dew point monitoring, which was relatively simple to put in place of the existing dryer, reduced energy costs by 60%, with an investment cost of £7,500. The payback for this upgrade was nearly 14 months. Another case study for a somewhat larger system where we had a heated purge dryer from Dominic Hunter, which was inefficient at that point. Some of the heaters were no longer working, and it required a higher purge rate than the dryer initially needed, had obsolete componentry, and required an expensive overhaul, which was going to cost £10,000 per unit. The annual operating costs were £27,000 with an air loss of 540,000 cubic meters. The new system with dew point dependent switching, low compressed air loss of only 3% versus 20%, and continuous dew point monitoring, and again, third-party validated performance and 5-year parts warranty, reduced the operating cost from 27,000 to 6,200, or 83% air loss reduction. Despite the cost of the investment of £32,000, the payback was only 14 months again. So what do we do next? If you're interested in the content of this presentation, we're happy to share the content, but ideally we'd like to follow up with you and review your compressed air purification requirements. We can carry out an energy survey or a site survey with direct air, which may result in reducing your energy cost by up to 90%, reducing maintenance costs, increasing your system reliability and site air availability potentially, reducing your carbon footprint, improve air quality, and the new systems also have a higher degree of control with remote control options available and real-time monitoring of dew point and other system parameters. The new units will have a 5-year parts warranty and third-party validated performance. As we pointed out, payback is typically 12 to 13 months. This was my presentation so far, and I'm very happy to take questions, and I'll pass you on to Georgia, who will be leading the Q&A session. I hope there's a few questions from people. Please do add some more if you need to.
Thank you. Yeah, we've just got a couple here. First one is for you, Alan. It's just how long do data loggers need to be fitted on the compressed air system for?
Okay, we would typically, excuse me, yeah, we typically fit data loggers for a normal working week. That generally gives us the opportunity to view a system across, all of its different operating parameters, weekends, nights, etc. So typically 7 full working days.
Thank you. I think this one would be best for you. You talked about air purity in a bit more detail. So what is class 0 air purity?
Yes, this famous class 0. You may recall on one of the slides we had the ISO 8573-1 specification up. And as I said, the lower the number, the higher the air purity specification is. There is a bar for 0, class 0, and class 0 is defined as better than class 1, but it has to be specified per contaminant. So it could be class 0 for solid particulate, for water, or for oil, and that has to be specified. And then a level of allowable contamination will have to be specified as well. So class 0 is not 0 contamination, it's just a lower level of contamination than class 1, and it has to be either specified by the air user or the supplier of the system. So for example, class 0 for total oil content would have to be below 0.01 milligrams per cubic meter, which is class 1. So we supply a system where we state a class 0 total oil content on our oil-free air systems, where total oil content is below 0.003 milligrams per cubic meter. So that's lower than class 1, but still an actual value that is above 0. Another requirement for class 0 is that it has to be measurable. And 0.003 milligrams per cubic meter is probably around the limit of what we can measure down to in terms of oil content. Thank
Lovely.
you.
Thanks. Another one for you whilst you're here as well. How do I know how much my current dryer's running costs are?
Yes, that would be probably best worked out from an energy survey that we can do on site. So you can measure the amount of air that the dryer is using for regeneration. We can measure the power requirement of the dryer. Sometimes dryers have inbuilt controls that tell you how much it's using, and we can establish whether it has a functioning dew point dependent switching as well. So we can work out from that what the actual running costs are of the dryer. And then we can do a comparison with what the new dryer would use in terms of energy costs, if that's relevant, and then work out a payback period on the basis of that.
Lovely. Sounds good.
Thank you.
Thank you. The last two I think are both for you, Alan. So how often should I have a leak detection survey done on my compressed air system?
That's a good question. I mean, quite often companies will have it done annually, but obviously the more often that that people check for leaks, providing they can then get on top of those leaks, the better it is for the system. So there's that sort of weighing up maybe the cost of doing the leak detection against the savings that you're going to get. But I'd say at least annually, probably 6 monthly would be even more sensible. But the important thing once you do a leak detection is that somebody actually then actions those leaks and tries to repair them.
Great, thank you. And the last one, I think. So what do direct air charge for a compressed air system energy assessment?
Okay, so the initial assessment is free of charge. So yeah, we will come to anyone's site, have a conversation, have a look at the system, and we'll do that free of charge. And then we'll assess what's needed, because depending on the complexity of the system, is when we can determine, what we're actually going to fit in order to get some good data that we can then provide some feedback to the customer.
Lovely, thank you. I think that's all for the questions. If anybody has any others, you can contact me after, that's no problem.
Thank you.
Thank you very much.
Okay. Thank you so much to everybody who's here for joining the webinar today. If you have any questions, please feel free to reach out to us, and we look forward to seeing you at future events. Have a lovely day.
Thank you.
Thanks.
Thank you.